The suction tube delivers oil to the gear-driven oil pump. The gears in the oil pump supply oil pressure to the lubrication system. At normal operating temperature, minimum oil pressure at low idle is 20 psi. At no load-governed speed, the oil pressure will reach 35 to 45 psi. The lubricating oil high-pressure relief valve in the oil pump limits the maximum output of the oil pump. This valve is held closed by spring force. If the pressure from the oil pump reaches approximately 130 psi, the relief valve opens and allows some oil flow to return to the oil pan through an opening in the pump. The oil pressure regulator position is controlled by engine oil pressure. This regulator controls the system oil pressure by bleeding off excess oil flow to reduce the pressure to the desired level. Oil flowing through the open regulator is returned to the inlet side of the oil pump. The pump then delivers the lubricating oil through an internal vertical passage in the engine block to the oil cooler housing. Oil flows from the front of the oil cooler housing to the oil thermostat. If the oil is cold, the thermostat will be opened through the center of the thermostat. Bypassing the oil cooler when the oil is cold helps the oil to reach operating temperature more quickly, which reduces engine parasitic loads and improves efficiency. As the temperature of the oil increases, the thermostat closes off the oil cooler bypass passage and directs the oil flow to the transfer tube in the oil cooler housing. This transfer tube is shaped to balance the flow of oil into the two oil cooler elements. The oil is cooled as it flows through the low-restriction oil cooler elements, and coolant is passed on the outside of the plates. Oil from the cooler or the cooler bypass passage flows to the combination oil filter. The new FleetGuard Stratapore combination oil filter combines full flow and bypass filtration into one innovative package called the Venturi Combo. This filter provides 30-micron filtration of oil passing through the full flow media and 10-micron filtration of oil passing through the bypass media. This filter eliminates the need for a separate bypass oil circuit. 15 to 20% of the flow passes through the bypass media, with the remaining oil flow passing through the full flow media. The bypass media is more efficient at removing sludge and fine particles from the oil. By increasing the flow through the bypass media, the filter provides increased uptime, better engine protection, reduced wear, and lower operating costs. The oil filter bypass valve is designed to protect the engine in case of low oil flow through the oil filter. This valve opens when the pressure differential across the oil filter element is greater than 125 psi. This maintains oil flow if a filter becomes plugged and prevents filter collapse due to high pressure differential at cold startup. The turbocharger oil supply line connects to a fitting in the oil filter head. The supply line directs the filtered oil under pressure to the turbocharger. Once in the turbocharger, the oil flows to the bearing journals and the thrust bearing to cool the turbocharger. Once the oil is supplied through the bearings, it flows under gravity back into the engine oil pan through the turbocharger drain line. The remaining cooled and filtered oil enters the oil circuit in the block through a cast passage. Oil entering the main oil rifle on the exhaust side of the engine splits and travels to the front and rear of the engine. 7 angled transfer drillings connect the main oil rifle with the 7 main bearing saddles. Oil flows down these drillings to the main bearing upper shells. The groove in the upper main bearing shell directs the flow of oil into the bearing surface. From the main bearings, oil enters the cross drillings in the crankshaft. Oil in the crankshaft flows through cross drillings to the connecting rod journal bearings. Some of the oil at the rod bearing surface flows through a drilled passage in the rod to lubricate the piston pin. On the exhaust side of the engine, oil travels to the overhead through vertical passages at the front and rear of the engine block and cylinder head. These passages supply oil to the center of the valve rocker shafts. Oil travels through a center drilling to supply oil to each of the rockers. Cross drillings in the shaft allow the oil to transfer from inside the shaft to the rocker lever bores. If the engine is equipped with engine brakes, the drilling in the center of the rocker shaft supplies oil for brake activation. Additional information about the engine brake can be found in the engine brake course. Cross drillings in the valve rocker shafts connect with a drilling in the head. This drilling supplies oil to the camshaft bushings. Oil at the front and rear of the main oil rifle enters a cavity on the front and rear face of the engine block. Oil entering these cavities flows across the block to the fuel pump side of the engine. Part of the oil enters each end of the fuel pump side main oil rifle and flows toward the center of the block. Vertical drillings intersecting this piston cooling oil rifle provide a flow path for oil to the piston cooling nozzles. The piston cooling nozzle is held in position by a special drilled cap screw. Oil from the fuel pump side main oil rifle feeds through the cap screw and into the piston cooling nozzle. The piston cooling nozzle bodies are made of a composite material and targeted to control the oil spray. Oil from the nozzles is directed to the underside of the piston to cool the piston head for each cylinder. Oil on the fuel pump side of the engine also flows to the overhead through vertical drillings at the front and rear of the engine block and cylinder head. Oil transfers from vertical drillings through a groove in the outer diameter of the front and rear camshaft journals. A cross drilling in the journal supplies oil to the oil rifle in the center of the camshaft. Cross drillings in the camshaft supply oil to each of the remaining injector camshaft journals. The groove in the front and rear camshaft journals also direct oil flow to the injector rocker shafts. A center drilling through each of the shafts and cross drillings provide lubrication for the injector rocker levers. Oil flow from the overhead drains into a passage at the front and rear of the fuel pump side of the cylinder head. At the rear of the engine, oil flows directly back to the oil pan. At the front of the engine, oil flows through an opening in the injector camshaft retainer and into the gear cover. This provides splash lubrication for the front gear train before the oil returns to the oil pan. The slotted opening in the gasket, along with the channel in the rear face of the gear housing, provides a flow path for oil to transfer to the air compressor and the oil pressure regulator in the oil pump. The channel in the back of the gear housing is connected by drillings in the block to the pressure regulator in the oil pump. The pressure regulating valve is held in the closed position by spring force. When the pressure from the sensing line reaches approximately 40 psi, the valve opens. Oil flow through the open valve returns to the inlet side of the oil pump through internal drillings in the pump. Passages in the gear housing also direct the flow of oil to a drilling in the air compressor mounting flange. Oil flow in the air compressor lubricates the compressor crankshaft, cylinder, and connecting rod. From the air compressor crankcase, the oil drains through the gear housing and returns to the oil pan. A passage in the front face of the engine block aligns with a drilling in the lower idler concept gear shaft. Oil flowing through this opening lubricates the idler gear and shaft. A passage connected to the vertical drilling in the engine block supplies oil to the adjustable idler spacer. Oil flowing through this opening is dedicated to lubricate the adjustable idler gear shaft. The lubricating oil flow begins as oil is drawn from the oil pan through a screen in the end of the rigid internal suction tube by the gear-driven oil pump. The suction tube configuration depends on whether the oil pan is to be mounted as a front or rear sump configuration. The standard oil pan for the X-Series engine has an oil capacity of 12 gallons. With filters and coolers, the total system capacity is 13 gallons. Other capacities are determined by the application of the engine.